putting in a decimal? Yes, I divided all those numbers by 10 by putting in a decimal point. Now I'm going to write the name of the planet and the numbers. Mercury, Venus, Earth, Mars. So, what do the numbers mean? Do you remember from the reading? It is the distance of the planets from the Sun? Right. In astronomical units, not perfect but tantalizingly close. The value for Mars is by 6 or 7% or so. It's within 10% of the average distance to Mars from the Sun. But I kind of have to skip the one after Mars for now. Then Jupiter's right there at 5 point something, and the Saturn is about 10 astronomical units from the Sun. And well, this pattern is known as Bow's law. It isn't really a scientific law now in the sense of predicting gravitation mathematically. Mathematical. Mathematically or something, but it's attempting a pattern in the spacing of the planets, and it was noticed by Bose hundreds of years ago. Well, you can imagine that there was some interest in why the 2.8 spot in the pattern was skipped, and but there was nothing obvious there. In the early telescopes, then what happened in the late 1700s? The discovery of another planet? The next planet out, Uranus, after Saturn, and look, Uranus fits in the next spot in the pattern pretty nicely. Not perfectly, but close. And so then, people got really excited about the validity of this thing and finding the missing object between Mars and Jupiter. And the telescope, remember, were getting better, so people went to work on finding objects that would be at that missing distance from the Sun. And then, in 1801, the object Ceres was discovered, and Ceres was in the right place, the missing spot. But it was way too faint to be a planet. It looked like a little star, and because of its star-like appearance, it was called an asteroid. Okay, aster is Greek for star, as in astronomy. And so Ceres was the first and is the largest of what became many objects discovered at the same distance. Not just one thing, but all the objects found at the distance from the asteroid belt. So the asteroid belt is the most famous success of this Bose law. That's how the asteroid belt was discovered. 이게 뭐 렌즈가 였죠,
Putting in a decimal?
Putting in a decimal?
Yes.
Yes.
I divided all those numbers by 10 by putting in a decimal point. Now I'm going to write the names of the planets under the numbers. Mercury, Venus, Earth, Mars. So what do the numbers mean?
What does the numbers mean?
Do you remember from the reading?
Is it the distance of the planets from the Sun?
Right. In astronomical units. Not perfect, but tantalizingly close. The value for Mars is off by 6 or 7% or so. But it's within 10% of the average distance to Mars from the Sun. But I kind of have to skip the one after Mars for now. Then Jupiter's right there at 5 point something, and then Saturn is about 10 astronomical units from the Sun. Well, this pattern is known as Bohr's law. It isn't really a scientific law, not in the sense of predicting gravitation mathematically or something, but it's attempting a pattern in the spacing of planets, and it was noticed by Bose hundreds of years ago. Well, you can imagine that there was some interest in why the 2.8 spot of the pattern was skipped. But there wasn't anything obvious there in the early telescopes. Then, what happened in the late 1700s? The discovery of
another planet?
The next planet out, Uranus, after Saturn. And look, Uranus fits in the next spot in the pattern pretty nicely. Not perfectly, but close. And so then people got really excited about the validity of this thing and finding the missing object between Mars and Jupiter. And telescopes, remember, were getting better. So people went to work on finding objects that would be at that missing distance from the Sun. And then in 1801, the object Ceres was discovered. And Ceres was in the right place, the missing spot. But it was way too faint to be a planet. It looked like a little star. And because of its star-like appearance, it was called an asteroid. Okay? Aster is Greek for star, as in astronomy. And so, Ceres was the first and is the largest of what became many objects discovered at that same distance. Not just one thing, but all the objects found at that distance form the asteroid belt. So, the asteroid belt is the most famous success of this Bohr's law. That's how the asteroid belt was discovered.
Excuse me,